Hello, my presentation is Recoupling the Long-Term Relationship Between People and the Prairies, how bioarchaeology can help us understand the fire ecology of tallgrass prairies. My name is Michael Aiuvalasit. I'm an archaeologist with the Illinois State Archaeological Survey. We are one of the many state scientific surveys housed at the Prairie Research Institute located at the University of Illinois at Urbana-Champaign. Now, before I begin, I must state that as a land-grant institution, the University of Illinois at Urbana-Champaign has a responsibility to acknowledge the historical context in which it exists. In order to remind ourselves and our community, I want to begin my talk by recognizing that we are currently on the lands of the Peoria, Kaskaskia, Piankashaw, Wea, Miami, Mascoutin, Ottawa, Sauk, Nausaki, Kickapoo, Potawatomi, Ojibwe, and Chickasaw nations. It is necessary for us to acknowledge these Native nations and for us to work with them as Illinois moves forward as an institution. Over the next 150 years, we will be a vibrant community inclusive of all of our differences, with Native peoples at the core of our efforts. Again, my name is Michael, and I'm an archaeologist. When you think of archaeologists, you might think of the standard definition of an archaeologist as someone who studies the material culture of people of the past, things like arrowheads and pottery sherds. Well, I'm an environmental archaeologist, which means my research focuses on the relationships between people and the environment. Quite often, I work on reconstructing ancient landforms and vegetations, which is frequently preserved in sediments and soils of old river and lake deposits. This puts me in unique situations, such as dangling off the side of a cut bank to record ancient flood deposits, or calf deep in a pond to collect algae so I can better understand similar ancient ponds. You may also ask, why would an archaeologist present research at Wild Things? My goal today is to show how modern day problems in ecology and resource management can benefit from the long-term perspective of archaeologists. I'll be presenting my first efforts to develop a new research project focused on understanding long-term dynamics of people in tallgrass prairies in Illinois, and focused on the greater Chicago area. So to begin with, we'll review just what is the Eastern Tallgrass Prairie. The Eastern Tallgrass Prairie Peninsula is an eastern extension of the Eastern Tallgrass Prairies. It extends across the Mississippi River into Illinois and is surrounded on three sides by the westernmost reaches of the eastern deciduous forests. In effect, this extension is sort of an ecotone. It's a porous transitional zone between two much larger ecological communities. Now, while grasslands have evolved and been present in North America for well over 1 million years, the Prairie Peninsula is a recent phenomenon. Grasslands moved into this region only after glaciers retreated and local climate became warmer and drier during the Middle Holocene. This period of time was only 8,000 to 5,000 years ago, which is but a blip in the long-term ecological history of grasslands. Now, getting grasslands in a temperate region to persist along in ecotones with forests is a challenge because wetter climates favor forests. Grassland ecosystems need three conditions to survive. First, grasslands are best adapted to semi-arid conditions, as grasses can tolerate drier conditions than forests. Second, grasslands need grazing pressures of herbivores to keep the regeneration of woodlands at bay. And finally, grasslands need fire coming at 1 to 3 year return intervals, also to keep down on the emergence of forests. Now, ecologists since the early 20th century have found aspects of the Eastern Tallgrass Prairie Peninsula perplexing. While the emergence of tallgrass prairies during the dry and hot Middle Holocene is understandable, its persistence into the late Holocene, when conditions became moister and cooler, is hard to understand. The precipitation levels over the last 3,000 to 4,000 years should support forests. Large herbivores like bison, which were present historically and are found archaeologically, don't appear to be present in large numbers. In addition, widespread fire at 1 to 3 return intervals is hard to sustain in the wetter conditions of this region, as there's a mismatch between the timing of when natural lightning occurs, which is your ignition source for the fires, and the seasons when there is abundant dry fuel to burn. Understanding these relationships is made all the more challenging because there's so little intact tallgrass prairie left to study. So as an archaeologist, I have to ask, what about people? Ancestors of Native Americans arrived in Illinois over 12,000 years ago. We find Clovis points, the spear points of the earliest peoples in the Americas, all across the state. Yet when they moved into this region, there wasn't a tall eastern tallgrass prairie. Instead, there were fire-sensitive forests of elm, birch, ash, and sugar maple. The implications of this is that there has never been a time when the eastern tallgrass prairie peninsula has not had people living in it. And early historical accounts show Native Americans used fire to manage grasslands across this region and other areas of the plains as well. However, there's no smoking gun for the use of fire in prehistory in this region. If there's sort of one axiom to remember or to know, is that where there's people, there's fire. Homo sapiens evolved in the grasslands of Africa, and harnessing fire for cooking to more efficiently turn food into calories has been hypothesized as an essential step in the early evolution of humans and pre-modern humans. Now, looking to examples across the world today of people who do traditional practices in burning, we first turn to the Aboriginal Australians, who have an unbroken tradition of using fire to manage grasslands. Ecologists have found that traditional burning, known as fire stick farming to encourage food production, not only increases the amount of food availability in grasslands, but it also just enhances biodiversity of these ecosystems. Native Americans across the Western US have a long tradition of fire use, which are increasingly being recognized by state and federal resource managers as being necessary to maintain forest health. Echoing Aboriginal Australians, I'm reminded of a quote by Paul Tosa of Jemez Pueblo, who was a collaborator on a fire ecology project I was involved with in New Mexico. Rather than viewing fire as a destructive force, he says simply, fire adds richness to the land. This richness both reflects increased biological productivity, but also the creation and endurance of cultural landscapes, places that have meaning to people, and places where today Native communities continue to enact tribal sovereignty over their lands. And finally, another example is that fires are still used by ranchers in unplowed parts of the central Great Plains to support the growth of grasses favorable to herbivores, a term referred to as pyrrhic herbivory. Now, the type of herbivore may be different than what it was in the past, but the practice remains. You might not realize this, but there are a lot of archaeological sites in the greater Chicago area. There are over 7,200 prehistoric Native American archaeological sites reported across the region. Now, these sites reflect the long-term relationships between people and the local environment. We can't rule out that fire may have been an important tool with which Native Americans shaped local ecosystems. However, no one has really addressed this hypothesis with evidence. Now, those of you may turn to this question, well, how is understanding whether or not humans influence prairie ecosystems using fire in the past relevant to today? First, I'm sure we all recognize that prairie restorations need fire. What we don't know is whether or not land managers using prescribed burns are mimicking lightning ignitions that can't set off large fires in our fragmented prairies, or are instead following in a long tradition of Native American fire practices. Burning with intent by Native Americans may end up having fires happening at different frequencies and scales than what you would expect in lightning ignitions. Regardless of that, though, I mean, it's important, we all have to agree that prairies need more fire. A 2016 study by the Illinois Prescribed Fire Council found only 9% of managed land that could be being burned in the state is. We will need to do a lot more burning to maintain the few intact, high-quality remnants of prairie, as well as to continue important and necessary efforts to restore prairie. Having better understanding of why we are doing what we can do, why we're doing what we do can only help justify our efforts. The other reason is that by restoring prairie, we're creating fire-dependent ecosystems, often in places where there's no historical memory of fire or in and around urban settings. This places us in a unique position in regards to managing the wild-urban interface, or WUI. Typically, WUI is conceptualized as places where urban development encroaches onto fire-prone landscapes. Think of summer homes in the mountain forests of Colorado or the rural exurbs of Northern California where they've had these horrible wildfires. Newly restored prairies in and around suburban and urban areas meet the definition of WUI. According to Radloff 2018, the acreage of WUI has increased between 1990 and 2010 in Cook, DuPage, and Grundy counties, while holding steady in Kane and Kendall counties. So we're actually creating a new WUI. Therefore, we need fires to occur in places and communities that right now have little tradition or recent history of living in and around fire. Now, the archaeological record in other regions, such as the southwestern US, show us that communities can live sustainably in fire-dependent WUI for hundreds of years if and when they actively manage fire risk. What lessons might we learn by studying local examples from prehistory? A hypothesis is that anthropogenic burning by Native Americans in prehistory led to the persistence of the eastern tallgrass prairie peninsula as a long-term coupled socio-ecological system. I believe this hypothesis can be evaluated by pairing archaeological and paleoecological records with a focus on studying sediment proxies that preserve the relationship between people, herbivores, grasslands, and fire, and then testing the significance of different variables in a computer simulation. I intend to do this study to test this hypothesis through combining archaeological and paleoecological studies at Dick Young Forest Preserve, which is part of the Forest Preserve District of Kane County. It's located west of the Fox River on the easternmost extreme of the Prairie Peninsula. The highlight of Dick Young Forest is Nelson Lake, a natural kettle lake formed on the St. Charles Moraine. This preserve consists of a mix of restored prairies, forested bluff edges, and wetlands. This park is heavily used by the public. In the 4 days I spent there this summer, I encountered running clubs, mountain bikers, bird watchers, teenagers up to no good, and contractors and delivery drivers taking advantage of the picnic tables and restrooms on their lunch break. It's my first time being there over the summer, but I can tell you it felt like a very typical public nature preserve that I've encountered all across the country in my work and just as in recreation. Yet, unlike so many of those places, I don't think little do people know that Nelson Lake also happens to be one of the best studied paleoecological localities in the eastern tallgrass prairie peninsula. In the late 1990s and early 2000s, a team of researchers from the University of Illinois and the Illinois State Museum, led by Dave Nelson, reconstructed the relationships between vegetation, fire, and climate over the last 10,000 years from the sediment core extracted from Nelson Lake. Using methods here, they were able to extract a 12-meter long core in which they found layer upon layer of muds archiving past environmental conditions. Pollen records showed a shift. Let me show you that here. So on top here, pollen records showed a shift over 8,000 years ago from vegetation dominated by fire-sensitive trees to one dominated by grasses. Proxies for aridity, the dashed line on the top chart, come from reconstructions of lake levels of Nelson Lake, derived from shifts in species of ostracods and oxygen isotope levels. And they found that this shift in vegetation corresponds to the more arid conditions in the Middle Holocene. Now, the frequency intensity of fire is reflected in changes in charcoal concentrations in the bottommost chart, with a corresponding increase in fire in the Middle Holocene as well. From this combined record, they argue for the importance of climate and an increase in fire for the establishment of the eastern tallgrass prairie peninsula in the Holocene. Now, what these researchers did not appreciate, however, is that Nelson Lake is surrounded by archaeological sites. Archaeological surveys in 1991 and 2007 by Doug Cullen found over 20 archaeological sites, most of them prehistoric, in the immediate watershed of Nelson Lake. Most of these sites are on bluff edges overlooking the lake, Diagnostic artifacts recovered show that these sites span from the late Paleo-Indian period all the way to the late prehistoric woodland period. The majority of these sites have archaic period artifacts, which overlaps when the tallgrass prairies came to dominate the region. This past summer, I went and conducted limited archaeological testing at some of these sites. I wanted to assess how well preserved these sites are. Typically, archaeological sites in settings such as these are heavily disturbed by historic plowing, which then limits our interpretation as archaeologists to reconstruct past behaviors from the artifacts recovered. Basically, everything just gets all mixed up by the plow. By taking low impact soil cores at some of these sites, I was able to preview the stratigraphy of the sites and identify that many of the sites along the forested bluff edges escape plowing. This means that these are promising sites for undertaking future archaeological investigations. So what I propose when it comes to new archaeology is to link the cultural histories of the prehistoric Native American occupations through new archaeological excavations at these sites. Now, the types of artifacts we find on the surface during our archaeological surveys are really not sufficient enough to work out the chronology of when people were at these sites and what they did. New test excavations are going to be necessary, which would allow us to directly date the cultural features, things like hearths and storage pits that are found still preserved. Then by analyzing the artifacts that we find in these excavations and using radiocarbon dating to date these sites, we should be able to get at a series of questions about what people were doing around Nelson Lake. Were occupations only seasonal encampments, or were they year-round? Were people hunting? When and how? And were perhaps people starting to farm along Nelson Lake as well? All those kinds of things about how people were living are in fact informing us about the resource decision making that people were going through, but over thousands of years. Now, in addition to the archaeology, I will collect a new core from Nelson Lake to apply new analytical techniques to the paleoecological record. Since the study published by Dave Nelson in 2006, there have been a number of new ways we can tackle these kinds of research questions from lake cores. Now, and the original study only published the results up to 3,000 years ago. So there's 3,000 years of environmental histories that have yet to be published and have yet to be fully analyzed, which is really important for looking at the late prehistoric and early historic changes to the environment. So some of the new analytical approaches include the counting and measurement of charcoal. Using computer-aided technologies, we can count and measure charcoal and develop a much more finely resolved record of the fire frequencies and intensities, which would allow us to get an opportunity to look at shifts in vegetation patterns between burning of woody versus herbaceous plants. We also anticipate looking at the pollen record. The first study had a great pollen record, but we can get more samples to flesh that record out, which will allow us to register subtle shifts in vegetation within some of these time periods, as well as constrain the timing of when the really big shifts in vegetation happened. Now, archaeologists can now look beyond the traditional archaeological record to register the presence of humans in prehistory in other ways. Fecal stanols, which are quite literally traces of the human gut biome and cholesterols expelled in our waste, actually preserved in lake sediments. The example of this, sort of the case study of this so far, is a study done on a lake near the archaeological site of Cahokia, which is the largest prehistoric city in North America and is located in southern Illinois. By applying this technique here, we can get a measure of the relative intensity of human occupation around Nelson Lake from the same core that we'll get these other proxies from, which allow us to directly correlate the shift of the culture history to the paleoenvironmental record. And we can do this kind of work here at the University of Illinois, at the Illinois Sustainable Technology Center. Biochemists who work there can do this kind of stuff as well. Now, thinking about herbivores, understanding the degree to which the presence and type of herbivores may change relative to vegetation, fire, and human histories is important. Do we see shifts in herbivores relative to the shifts in the broader ecological communities? Do we see shifts relative to hunting pressures by people through time? Those are things that we don't know much about. Now, proxies for herbivores can be identified in the presence of a dung fungus, believe it or not, called Sporormiella, as well as in the recovery of ancient DNA, both from the core samples. Sporormiella only grows on the dung of herbivores like deer or bison, and it accumulates in lake deposits. It serves as a measure of the presence or absence of herbivores, but it can't tell us which particular species were present. Ancient DNA, extracted and sequenced from sediments, has the potential to do that. And recovering ancient DNA from this context would be a game changer when it comes to reconstructing ancient ecosystems. And there are researchers here at the Illinois Natural History Survey, as well as the U of I, who undertake this kind of cutting edge work. Now, how to bring all this together? Evaluating hypotheses regarding phenomenon that we can't really see stuff that happened in prehistory, and then relating it to questions we don't have clear answers for is very challenging, admittedly. Now, this is where computer simulations can come into play. Now, by setting up models of alternative hypotheses as to the relationships between climate, fire, vegetation, herbivores, and people, with explanations of variables that we think are important, we can make stronger arguments to support the claims that we make and how we evaluate the data. Here we can use a model that simulates expectations of the type of charcoal records we would expect to be produced under different scenarios. Now, many variables go into the production of this model, but the archaeological and paleoecological records in this study will be able to generate the outputs we need. And again, it looks very complicated, and it is very complicated because we're studying very complicated things in the past. So what might this look like? The goal is to get something that looks like this: a direct comparison between the chronology of fire histories produced in our charcoal record from the lake core and alternative predictive scenarios of charcoal concentrations we expect under different conditions through time. These alternative scenarios can be the type and quantities of charcoal we'd expect in fires in woodlands versus fires passing through grasslands, or the amount of charcoal that would accumulate under frequent small grassland fires set by Native Americans versus perhaps less frequent but larger natural fires tied to lightning-induced fires, perhaps during periodic droughts. Now, the degree to which the real-world observations match the model can then be evaluated. And as long as all the variables are justified and out in the open with other researchers, that way others can assess and critique these findings. So for example, let's look back at this Nelson Lake, this charcoal record produced by Dave Nelson in his publication. Looking at this now, we can ask ourselves, what might these big spikes mean? What might these big spikes at 6,200 and 3,750 or so reflect? Might those reflect changes in fire regimes caused by people? Might they reflect, subtle differences in shifts and subtle differences in drought periodicities? These are the kinds of questions that we can set the models up to test and see whether or not the charcoal records match them. And also only by linking these sort of different analyses together, things from archaeology and paleoecology, and doing them in a disciplinary way, can we tackle these kinds of questions. And at least that's the way I can see it, so we can tackle these kinds of questions. So in conclusion, I first want to share the sources that I brought up in this study, because again, this is a project that's just starting off, so it's mostly building upon the ideas put together by others. So feel free to pause the video if you need to write down, follow up on any of these source material. And of course, I want to invite people to reach out with questions and comments. Feel free to contact me. I look forward to hearing from you and sharing my interests and hearing your interest in this type of work. And of course, this is just a project starting off. There are many to thank already. The Kane County Forest Preserve for being able to get out and begin with their support to start work, as well as the Historic Preservation Division of the Department of Natural Resources, the folks at Wild Things, as well as a number of researchers, both archaeologists and ecologists, who have been more than willing to help get me up to speed here and to help out. So again, thank you very much, and enjoy the rest of your conference.